Welcome to our lecture online. The third example of the Euler equation comes when we're going to have imaginary roots. So here's an equation that will probably lead to imaginary roots, and let's see what the equation or the solution for this equation then looks like. We know that the general format should be something like this. And so we're going to start with this as being part of the solution, and then the first derivative and second derivative look like that. Before we go ahead and plug y prime, y double prime, and y back into the original equation here, we're going to rewrite it into its standard form, which means we're going to divide everything by t squared. Then we get the following: y double prime plus, this will be 1 over t times y prime plus 4 over t squared times y equals 0. And now we go ahead and plug in the equivalence. So the y double prime becomes equal to this. We end up with r times r minus 1 times t to the r minus 2 power plus 1 over t times y prime, which is r times t to the r minus 1. And then here we have plus 4 over t squared times y, which is t to the r power equals 0. So next, what we want to do is we want to multiply both sides of this equation by t squared to get rid of the denominators. When we do that, here we get r times r minus 1 times t to the r power, because t squared times this, the negative 2 cancels out. And here we have plus, we get rid of the 1 over t, we end up with r times t to the, well, now this will be r power, because one of the t's goes here, one of the t's cancels out this. And finally, the t squared will cancel out. We get 4t squared equal 0. Oh, not t squared. This is t to the r, and that's supposed to look like an r. There we go. That's better. Now we'll factor out on the left side a t to the r. And we have left an r squared, a minus r, a plus r, and a plus 4. And that should equal 0. Now, of course, t to the r cannot equal 0, because if it does, we don't have a solution. That means what's in the brackets must equal 0. And if we simplify that, we get r squared plus 4 equals 0, or r squared is equal to negative 4. Of course, when we take the square root of both sides, we have to take the square root of a negative 1, which means that r will be equal to plus or minus 2i. Now, the general format of the imaginary root is that r will be equal to some constant that's not the real part of the imaginary number, plus or minus, that would be b times I. So we have the bi part, but we don't have the real part of the imaginary root. The general solution will look like this. Y will be equal to c1, that would be t to the a power, times the sine of b times the natural log of t, and that would be plus c2 t to the a power times, not the sine, we usually start with the cosine. It doesn't really matter, of course, which order we put it in, but it's typically the cosine is written first, then we write the sine of b times the natural log of t. Now notice in our case, b is equal to 2, a is equal to 0. So in our case, we end up with y is equal to c1 t to the 0 power times the cosine of b, which is 2 times the natural log of t, plus c2 t to the 0 power times the sine of, that would be 2 times the natural log of t. And of course, t to the 0 power is equal to 1. So the final solution in this case will be y equals c1 times the cosine of 2 times the natural log of t plus c2 times the sine of 2 times the natural log of t. And that will be the solution of the Euler equation in the case that we have imaginary roots. And that's how it's done.